So then this one is regarding the potential difference. So you have a series circuit again. Maybe I would redraw this and put the resistors next to each other. So I have resistor 1, resistor 2. So this is the EMF. Then you can have a potential difference across resistor 1 for V1 and then another potential difference here for V2. So the PD, right? The V here is splitted into two parts. So V1 and V2. So in order to find V, you will need to add up V1 and V2, which also means that if you want to find V1, you can take the V minus V2. If I have a multi-component, that means okay, more resistors like this. So R1, R2, R3, V1, V2, V3, like that. So V in this case would be the sum of all three. So if you have indefinitely many resistors, your V will be the sum of all the potential difference across all the resistors. Okay? Yeah. So this case here, then you say calculate V. So V equals to IR, then you find the potential here. Then V equals to IR, you get this one, which is here. So then you add up. Okay. You can also do it in another way, yeah, which is not making use of this property anymore, just like this. You do it the other way, this is also possible. So instead of using the V equals to V1 plus V2 property, you can just use the resistance, combine all of them, then use V equals to IR. You would achieve the same result, just saying. If you need help, please indicate. V equals to IR. Yeah. So then resistance, this is a recall because I've done this before. You know what is this, so I'm not gonna go into it. So they say calculate the value of V2. It's actually relatively simple. We can rearrange the resistors. Yep, yep. So become six volts here. This is damn easy. Series circuit R1 plus R2, yes. R effective equals to 12 ohms. This is 6 volts. And what is the reading on the ammeter? Also very easy. I equals to V over R, no 9 units. So we have two identical resistors. Then find the PD between P and Q. So I can put this as 1, 2, 3, 4. Then this is P, this is T. Wait, then PQ, Q is after the first resistor, so Q is here. Then R is here, then S is here. So find the PD between P and Q. So because the resistors are the same, so the PD across each resistor should be the same, because what you do is you take 12 divided by 4.
Yeah.
Yeah. Okay, then I want to do some some reminders here. Revise something. So because this is potential is 12, right? So positive side, negative side here. That means the potential here, right, at P, right, is 12 volts. And then when it comes back to the negative terminal, right, this side will be 0 volts. So from P to Q, right, over here will be 3 volts. Then so the potential here will also be 3, 3, 3. But okay, so down here is 12 volts. At Q, right, after the current passes through, at Q, it will be 9 volts. Then after the potential passes, the current passes through the QR resistor. So then it will become minus 3 again, 6 volts here. And then when it goes to S, it will be 3 volts. And then back to here will be 0. So it across each resistor, it drops by 3 volts. So now the PD between P and Q is 3. That's correct. Because later on you will have this concept again in some other question. So then they say Q and S. What's the potential difference between Q and S? Now got two resistors in between. So QT is 9. Because 3 here, 3 here, 3 here. Right, P and T. Because it's this side, right? 12 volts.
Yeah.
Determine the PD for the resistors P and Q. V equals to IR. So 0.5 times 4. Okay. Then Q, then IR again. So V equals to IR. I equals to V over R. So then, so you use this. So wouldn't it be 2 divided by 5?
0.4.
Yeah. So then needs to change here.
12.5 ohm.
So then R equals to V over I equals to 5 here divided by 0.4.
12.5.
R equals to V over I 12 divided by, when you do that, what you are doing is 0.2 amps, 12 volts. Then you have a R total here. So when you do R equals to V over I, what you found was the total resistance is,
then 60 minus 10 minus 30.
yeah, not people run into, right, is they use the wrong resistance, they use the wrong current, etc., etc., when they are given like a question with a lot of values.